Hello, hello, hello. Welcome once again to our SHS 3 Core Mathematics lesson brought to you by the Center for National Distance Learning and Open Schooling. My name is Lucy. Today we start with the topic integration. Integration is another addition to your examination syllabus. By the end of this lesson, you should be able to 1. Integrate basic expressions by the use of reverse differentiation. 2. Evaluate the constant of integration. And 3. You should be able to evaluate definite integrals. Integration as a reverse of differentiation. By now, you will be familiar with differentiating common functions and would have had the opportunity to practice many techniques of differentiation. In this unit, we carry out the process of differentiation in reverse. This is what is being referred to as the differential coefficient of a function. That is, being given the differential coefficient of a function, we try to discover the original function. This leads us to what is known as an antiderivative and integration. If y is equal to x to the exponent 4 divided by 4, then dy dx, I hope you remember, is equal to x cubed. We may write dy is equal to x cubed dx. The expression x cubed dx is called the differential of x to the exponent 4 divided by 4. Now, reversing the process of differentiation is called integration. It is indicated by the sign, the long S, that's the integral sign, in front of the differential. That is, if dy is equal to x cubed dx, then y is equal to the integral of x cubed dx. And that will be equal to x to the exponent 4 divided by 4. Again, if y is equal to x to the exponent 5 divided by 5, then dy dx is equal to x to the exponent 4. And dy will be equal to x to the exponent 4 dx. Reversing the process, we will have y to be equal to the integral of x to the exponent 4 dx, which is equal to x to the exponent 5 divided by 5. So we can generalize this. In general, if y is equal to x to the exponent n plus 1 divided by n plus 1, then dy dx is equal to x to the exponent n. And we can write dy as x to the exponent n dx. So to get back to y, we integrate. So y will be equal to the integral of x to the exponent n dx, which is equal to x to the exponent n plus 1 divided by n plus 1. So x to the exponent n plus 1 divided by n plus 1 is called the integral of x to the exponent n dx. The rule is first add 1 to the exponent n to get n plus 1 and divide x to the exponent n plus 1 by n plus 1 to obtain x to the exponent n plus 1 divided by n plus 1. This rule applies to all indices, positive, negative, and fractional, except for the integral of x to the exponent negative 1 dx. Good. Let's look at the constants of integration. We know that the differential of x squared divided by 2 is x dx. Therefore, if we are asked to integrate x dx, we will obtain x squared divided by 2. But it is not the only possible answer, because x squared divided by 2 plus 2, x squared divided by 2 plus 12, x squared divided by 2 minus 30, and many others are all expressions whose differential is x dx. The general expression for the integral of x dx is therefore x squared divided by 2 plus c, where c is the constant of integration. In the previous cases, the 2, 12, and negative 30 represent c. Now, every time we integrate, the constant of integration must be included. So, the integral of x to the exponent n dx is equal to x to the exponent n plus 1 divided by n plus 1 plus c. This is called the indefinite integral of x to the exponent n. I hope you understand. Let's take some examples. Evaluate the integral of x to the exponent 6 dx. The solution is, we are going to use a rule. So x to the exponent x dx, when we integrate, will give us x to the exponent 6 plus 1 divided by 6 plus 1 plus c. We simplify this and we have x to the exponent 7 divided by 7 plus c, where c is a constant of integration. B. We want to evaluate the integral of x dx. So the integral of x dx is equal to x to the exponent 1 plus 1 divided by 1 plus 1 plus c. That is when we use the rule. And that is equal to x squared divided by 2 plus c, where c is a constant of integration. Good. Remember, the rule is add 1 to the exponent and use the result to divide. And then you add c. So the integral of x to the exponent n dx is equal to x to the exponent n plus 1 divided by n plus 1. And for the case of indefinite integrals, add your constant of integration, which is c, to it. Good. So a constant coefficient may be taken outside the integral sign. That is, if we have the integral of 3x squared dx, we may rewrite that as 3 outside, then the integral of x squared dx, and then integrate. when we integrate this, we will just use the 3 to multiply. So 3, the integral of x squared dx is equal to 3 multiplied by x cubed divided by 3 plus c, where c is a constant of integration. And when we simplify that, it would give us x cubed plus c. Good. The integral of a sum is the sum of their separate integrals. This means that integration is also done term by term, just as we saw for differentiation. Let's take an example. Evaluate the integral of x squared plus x dx. Let's look at the solution. We are going to integrate each term separately. So the integral of x squared is x cubed divided by 3. And the integral of x is x squared divided by 2. Therefore, the integral of x squared plus x dx is equal to x cubed divided by 3 plus x squared divided by 2 plus c, where c is your constant of integration. B. Evaluate the integral of 5x to the exponent 4 plus 3x squared plus 2x minus 6 dx. Let's take the solution. So when we integrate them term by term, we will have 5 divided by 5x to the exponent 5 plus 3 divided by 3x cubed plus 2 divided by 2x squared minus 6x plus c. You don't have to forget the c in case of indefinite integrals. Simplifying this will give us x to the exponent 5 plus x cubed plus x squared minus 6x plus c. I hope that was simple. Good. C. Evaluate the integral of 2x plus 5 all squared dx. Now, in situations like this, it is good to expand first. So when we expand this expression, we will have the integral of 4x squared plus 20x plus 25 dx. Then we integrate. We are integrating them term by term. So that will give us 4x cubed divided by 3 plus 20x squared divided by 2 plus 25x plus c. Simplify that to get 4x cubed divided by 3 plus 10x squared plus 25x plus c. Good. Now let me give you an exercise. Integrate with respect to x. 1, x squared. 2, 3x to the exponent 4. 3, x squared plus x plus 3. 4, x minus 2 multiplied by x minus 1. If you did that well using the rule, then here are the answers. The integral of x squared dx is equal to x cubed divided by 3 plus c, where c is a constant of integration. I hope you remembered to bring your c. 2. The integral of 3x to the exponent 4 dx is equal to 3x to the exponent 5 divided by 5 plus c. 3. The integral of x squared plus x plus 3 dx is equal to x cubed divided by 3 plus x squared divided by 2 plus 3x plus c. That case, you integrated term by term, and you don't have to forget your c. 4. The integral of x minus 2 multiplied by x minus 1 dx is equal to x cubed divided by 3 minus 3x squared divided by 2 minus 2x plus c. And here I hope you first expanded before taking the integral. Good. Now I want us to take another aspect of this. We want to evaluate the constant of integration. The value of the constant of integration may be found provided the corresponding pair of values of x and y are known. Let's take an example to explain this. A. If dy dx is equal to 3x and the curve y passes through the point 2, 0, find an expression for y. Let's take the solution. We have been given dy dx. Dy dx is equal to 3x. So for us to get y, we will have to integrate. So y is equal to the integral of 3x dx. That will be equal to 3 divided by 2 multiplied by x squared plus c, where c is the constant of integration. But we were given the point 2, 0. We are told the curve passes through the point 2, 0. So at this point 2, 0, we can replace the value of x and the value of y in our integral. That will give us 0 is equal to 3 divided by 2 multiplied by 2 squared plus c. So 0 is equal to 6 plus c. And c is equal to negative 6. Now, after finding c, you don't stop there. You replace the value of c. So finally, y is equal to 3 divided by 2x squared minus 6. I hope that is clear. Good. The gradient of a curve which passes through the point 2, 3 is given by x squared. Find the equation of the curve. Let's take the solution of this question. We have been given the gradient which stands for dy dx. Dy dx is equal to x squared. The equation of the curve will be represented by y. Therefore, y is equal to the integral of x squared dx. Y is equal to x cubed divided by 3 plus c, where c is the constant of integration. We are also given that when x is equal to 2, y is equal to 3. That is from the point 2, 3. So we are going to substitute this in our solution. So we are putting the value of x and the value of y in place. in the equation y is equal to x cubed divided by 3 plus c. That gives us 3 is equal to 2 cubed divided by 3 plus c. So 3 is equal to 8 divided by 3 plus c, because 2 cubed is 8. When we work this out, we will have c to be equal to 1/3. Therefore, the equation of the curve is y is equal to x cubed divided by 3 plus 1/3. I hope it's becoming clearer. Let's take an exercise for this. 1. The gradient of the curve which passes through the point 2, 3 is given by x. Find the equation of the curve. If you do that correctly, you will have y is equal to x squared divided by 2 plus 1 as the answer. 2. The gradient of the curve which passes through the point 3, 8 is given by x squared plus 3. Write down an equation for y when x is equal to 5. Again, if you did that well, we are going to have y is equal to x cubed divided by 3 plus 3x minus 10. Good. Let us move on to definite integrals. We said for indefinite integrals, we will include the constant c. What do we do when we get situations where we have a definite integral? It has been shown already that the integral of x to the exponent n dx is equal to x to the exponent n plus 1 divided by n plus 1 plus c. That is in its indefinite form. This expression is called an indefinite integral, and it must contain the arbitrary constant, in this case c. For many other purposes, we may require the definite integrals, which are written as the integral from a to b of x exponent n dx. The values of a and b are called the limits, a being the lower limit and b the upper limit. The method of evaluating a definite integral is shown in the following examples. Example 4. 1. Find the value of the integral from 2 to 3 of x squared dx. Let's take the solution. The integral of x squared dx from 2 to 3 is given by x cubed divided by 3 from 2 to 3. This is equal to the value of x cubed divided by 3 when we put in 3 minus the value of x cubed divided by 3 when we put in the lower limit 2. So after integrating, substitute the limits, the upper limit first minus the lower limits. So we have 3 cubed divided by 3 minus 2 cubed divided by 3. That's when we simplify, will give us 27 divided by 3 minus 8 divided by 3, which is equal to 19 divided by 3, or 6 1/3. Good. Example 2. Find the value of the integral from 0 to 2 of 3x squared minus 4x plus 3 dx. Let's take the solution. The integral from 0 to 2 of 3x squared minus 4x plus 3 dx is equal to x cubed minus 2x squared plus 3x from 0 to 2. That means integrate from 0 to 2. Now we are going to substitute first the upper limit. So we have 2 cubed minus 2 multiplied by 2 squared plus 3 multiplied by 2 minus, then we substitute the lower limit in the same expression. That will give us 0 cubed minus 2 multiplied by 0 squared minus 3 multiplied by 0. We simplify that to get 8 minus 8 plus 5 minus 0, which is equal to 5. Good. Let's take the third one. Evaluate the integral from -1 to 1 of x squared plus 2 dx. Let's take the solution. Remember, integrate the expression term by term and then substitute your limits. So the integral from -1 to 1 of x squared plus 2 dx is equal to x cubed divided by 3 plus 2x from -1 to 1. That is equal to 1 cubed divided by 3 plus 2 multiplied by 1 minus -1 cubed divided by 3 plus 2 multiplied by -1. We'll simplify that to get 7 divided by 3 minus -7 divided by 3, which is equal to 7 divided by 3 plus 7 divided by 3, and that is equal to 14 divided by 3, or 4/3. Good. I want to give you an exercise again. Evaluate the following definite integrals. 1. The integral from 2 to 3 of 2x plus 3 dx. If you do that well, you will get the answer as 8. 2. The integral from 0 to 2 of x squared plus 5 dx. Again, you do that well, you will have 38 divided by 3 as your answer. 3. The integral from 1 to 2 of x multiplied by 2x minus 1 dx. Your answer will be 19 divided by 6. 4. The integral from 0 to 2 of x plus 1 in one bracket multiplied by x plus 2 in another bracket dx. Your answer will be 38 divided by 3. In each case, remember to reduce your improper fractions to mixed numbers. Good. In this lesson, we have learned that the indefinite integral of the function f of x, that is the integral of f of x, is another function. It is given by f of x plus c, where f of x is any integral or antiderivative of f of x, and c is an arbitrary constant. We've also learned that the definite integral of the function f of x between the limits a and b, that is The integral from a to b of f of x dx is a number. It may be obtained from the formula f of b minus f of a. You see that the s are different. The lowercase letter f of x is the original function, and the uppercase letter f of a, f of b is the integral. After you have integrated, the expression that comes out, that is the difference. So we have f of b minus f of a, where f of x is the integral or the antiderivative of f of x. This brings us to the end of our lesson. If you have been with us through SHS 1, SHS 2, and now SHS 3, then congratulations, you just completed the syllabus. In our next few lessons, we'll be taking you through revision work. I want you to join us again. Until then, bye-bye.